Hi there, ladies and gents. It's been a long while since I've been doing this project, doing the thermal panel as a heat exchange and source of energy for electricity. I've got a little set out here. Yeah, you should be able to see that. Of the final pieces. This is the heat exchange. I'll put that in shot. It's quite long, so this unit here is made of an aluminium block which is hollow. Inside is stainless steel wire wool. That will act as a means of transferring heat from the water to the metal itself, and obviously from the metal through to these. These are TEGs, thermoelectric coolers. When you give power to them, one side gets hot, one side gets cold. But if I heat one side and cool one side, I get power back out. These are solid state, so relatively simple. As for, again, the heat exchanger, which was the main problem of the whole build, I had to do it up in layers. I've got me a bit of plastic piping. This is radiator piping, so it can actually take the heat. That's the end cap. So what will come in is a slat inside the middle. Probably won't be able to show you that, but obviously that fills up. Each TEG will go across the front, down, and it fits 5, just 5 across here. And that's the outlet valve for when I fill the actual radiator up. So it will go that way around on the radiator, and that's just to bleed out the air and water to make sure the system's full. As for means of cooling, I've got these. This is part of a 250 watt heatsink for MOSFET drivers and stuff like that, it said. But it was one piece. Got a hacksaw. It was that. I chopped it straight down the middle. Took a bit of time. Smoothed them around the edges off. Took a bit of excess off on the end because I needed it 20 centimeters to fit exactly into that spacing. These are from, this metal is a part of a cover, side cover for a PC. It's actual metal sheets I've cut into a pattern, bent it up so that it fits on the hole. Got a rasp, drilled out the hole in the metal, and bent that round. Underneath here is a heavy duty drain block, a compound anyway. Then it's got heat sealant, gasket sealant, a gasket sealant, which is like liquid gasket sealant. It's quite good stuff. That's the stuff. Instant gasket. It's very good stuff. It can take high temperatures. It's very malleable. It fits in every gap, and it's ideal for this type of job. It works with fluids. Then finally layered by resin and fiberglass, and then topped off with this, because these points here is the weakest points. Obviously, this being a solid bit of metal, this being a whole pipe, that was the main problem I had, which was leaks. So that's heat exchange. Got the TEGs, all 10 of them, and I've got this compound. It's got some of me in there. It's called Servicol. I did have one before, which I've used repeatedly for other experiments, messing around with the TEG. The only hitch I had at the very, very end was obviously how do I stick that on there and make it stay on there. I would like to have used clips or screws, just something to hold it on from one side to the other. Got myself some big Jubilee clips. They are simply going to go around each unit and actually just Jubilee clip the whole lot together. Simple as that. So again, all this is experimental. TEGs have been used in various products, various ways before, but not as a thermal heat exchange for a thermal panel with the use of water. With most TEGs, I find with these ones anyway, it's the writing side that actually gets hot. and that side gets cold, plain side. So generally apply it that way. Heat source, that side down. Apply as much as you think you may need, but not too much, because it's just there to fill the gaps. Yeah, I'm just going to put on probably about that much. Yes, one thing to remember about these, they're ceramic, and ceramic breaks. So I guess you get the idea of how it's going to be. I'm not going to stick this on. Obviously when I'm working with that side it's stuck on, I turn it over, it's going to slide all about the place. So I need to now put the layer on this side.